In the previous video, we calculate the CPE value for leeward wall, windward wall, roof, and the leeward wall. Now we like to use the CPE value and all previous calculation to calculate the design wind pressures. Now to calculate design wind pressures, we need to get the two different cases because we have two different values for the roof. You can see the CPE has a two different value. This has a single value, but here we have two different values, so we are obtaining two different pressure value for the roof. So we need to get the two different cases, one for this first one and second one for this second CPE value. Now for this case, we can draw this diagram here, which is for the first case, and that first case is using this first CPE values. Now we have an equations to calculate that pressures, like design wind pressure is equal to 0.96 C aerodynamic safe factors, right? We found that in the previous video. In previous video, we found that design wind pressure is equal to P 0.96 aerodynamic safe factors. Now we're going to substitute these aerodynamic safe factors, and in this case we have different CPE value. All these values are constant. So in this case, for external aerodynamic safe factors, we have a CPE Ka, we have CPE Ka, KCE, KL, KP, KCE, KL, and KP. Now please note here we have a different CPE values. We have different CPE values. That's what the value is vary. And for the Ka value for the roof, we have 0.8, and for all other cases, all these factors for the these are 1 for all other cases. Only when you have a roof, the Ka value is 0.8. I can show that one. For the roof, we found the Ka value 0.8. All other factors we just found the one value for this case. Now if I substitute those values here and calculating the pressure, so once you calculate the pressure, this one is given in the kilopascal. So the UDL load is equal to that's in the week 2 we have taken some examples to calculate the UDL load from the pressures. So if the pressure is known, we can multiply by the perpendicular length. So the pressure something in kilopascals, or you can say kilonewton per meter square, that's times perpendicular length. Now for our case, the perpendicular length is 6 meters. I can explain it here. Now the wind is coming from this end, and this wind will create the pressure on this surface. Now we need to get the perpendicular distance. So if you can imagine, the pressures will be created here. Now the perpendicular to this pressure is the UDL load 6 meters, and that is the perpendicular. Like if I want to calculate the UDL load in these fashions, like a UDL load of this one, the perpendicular length with 6 meters. So 6 meters is given here, the center to center distance between these two four. So you can imagine, if I want to calculate the UDL load here, so we need to multiply this perpendicular 6 meters length. That's what I'm doing it here, and that's wind create the pressure over the surface, and we convert this pressure into UDL load. Now this is the case scenario here. So our UDL answer would be kilonewton per meter. So let's start with windward wall first here. So please note the CPE value is 0.7 in this case. So if I draw it here, this UDL load, I can calculate that pressure in terms of UDL load. I can calculate 0.96, which is this 0.96. And C aerodynamic safe factors, we can use this equation, and CPE value is 0.7, that is 0.7 here, so times 0.7, and Ka value for windward wall, Kc value for windward wall, Kl value for windward wall, and Kp value. So there are four ones, so I'm not writing it, but just I'm writing it one for all this one, and this whole pressure times, because now we need to get in the UDL. So this is kilopascals. You can imagine this is kilopascals times the perpendicular length 6 meters. That is give us the UDL load. So in that case, we can have a 0.96 times 0.7. I'm not typing 1, and then 36. So that gives us 4 kilonewton per meters for this case. Now the second one, you can see the second case is 0.9 up to here. So I'm just drawing it here up to somewhere here. We have this one, and that has a value of 0.9. So in this case, pressure equal to 0.96. That 0.96 is coming from here, times aerodynamic shape factor, and CPE value for this case is 0.9. So CPE value is 0.9, and the Ka for the roof is 0.8. So the Ka for roof is 0.8, and all other factors are 1. So that is the pressure, and then times by the perpendicular distance 6 meters. That's give us 0.96 times 0.9 times 0.6 times 6 give us 3.1 kilonewton per meters. So that is 0.8. So that's includes 0.96 times 0.9 times 0.8 times 6 is give us 4.1. So that is 4.1 kilonewton per meters. The second case that we're going to look is the one that is with the 0.5. So if I have it up to here and up to here, so that's give us the 0.5. So if I have this one here, pressure equal to 0.96 times 0.5 here, that is 0.5 CPE value, times Ka value 0.8, and times 6 meters. So that's give us 0.96 times 0.5 times 0.8 times 6 give us 2.3 kilonewton per meters. 2.3 kilonewton per meters. And the last one we have it here, that is here, and the last one has a value of 0.3. So we going to use same thing, 0.96 times 0.3, and the Ka value is 0.8, and times 6 meters. That give us 0.96 times 0.3 times 0.8 times 6 give us 1.4 kilonewton per meter. The last one is the windward wall, which we have 0.5. So in that case we have 0.96 CPE value 0.5 times 1, and it's times by 6 meters. So that's give us 0.96 times 0.5 times 6. It's give us 2.9 kilonewton per meters. Thank you very much. For the next video, I'm going to take the case for 0.5, 0.4, 0.40, and 0.1. These values not going to change for windward wall and leeward wall. Thank you.